All right, today's topic is about factoring quadratic equations. Now, when we're doing factoring quadratic equations, you'll see that it's very, very similar to factoring polynomials. It's pretty much the same rules, the same way of doing it. It's just that it's when the equation part comes into it, and we'll get to that when we start doing these examples here. So let's offer something simple, all right, something that we've been seeing before. Let's do x plus 3 and then times 4x minus 12 equals 0, okay? So this is something that you've seen before, very similar with the two parentheses, right? With polynomials, the difference is this equals 0 at the end, right? This equation, the equals 0 that makes this an equation, all right? So very simply, and this is the base part of it, right? To figure out how to factor this equation, we need to take both sets of parentheses and set them up equal to 0, okay? So real simple, we'll take our first x plus 3, and we do x plus 3 equals 0. And then we'll do our second set of parentheses, 4x minus 12 equals 0, okay? So when we do that, now we're just going to solve for x on each little equation, all right? So on the left one here, it's a one-step equation, right? To get the x by itself, we have a positive 3, opposite positive 3. We got to move it minus 3 here, cancel this out, and x equals 0 minus 3, which is negative 3, okay? And then our second equation, two-step equation, right, to solve for x, we have to move this 12 first, because it's minus to cancel out. We need to do plus 12 here, that cancels this. We're going to bring down our 4x, and 0 plus 12 is 12. And our last step to get the x by itself, we need to divide by 4 on both sides to cancel, and x equals 12 divided by 4, which is 3. Okay, and we're done, and that's it. So our answers are x equals 3, or x equals negative 3. Okay, that's it, we're done. Simple, right? And that's all we got to do. So when you see the situation where you have two sets of parentheses here, set up equal to 0, take each set of parentheses, set it each one equal to 0, and then just solve for x, or solve for the variable that it gives you, okay? All right. So let's move on to, if we go one step further, x squared minus 2x minus 8 equals 0, okay? So once again, in all these ones, right, we're all equaling to something, right? And in many cases, it's going to be equal to 0. And so that's what we're doing with this one here. So as we've seen here, factoring trinomials, right? We've done this in the past, where we have our x squared minus 2x minus 8, and we have to have our two sets of parentheses here. We know that's where we're going. Excuse me. All right. We have x squared in front by itself, so it means we're going to start each parentheses with an x, and then we need to figure out two numbers that multiply to 8, right, and add or subtract to 2, okay? Now in this case, because we have a minus 8 here, all right, or a negative 8, it means we have to have two numbers that subtract to get to negative 2, okay? So we know we're going to have a plus and a minus in our parentheses because we have to multiply positive negative to get a negative 8. So two numbers multiply to 8, well, we have 1 and 8, right? But when we subtract 1 and 8, do we get 2? No, so then we can't do that. How about 2 and 4? Right, 2 and 4, 2 times 4 is 8, and then we can do 2 minus 4. Yes, we do get negative 2, so we'll use this, right? Now, because our 2 in the middle here is negative, it means we have to, our bigger number is going to be negative. So our 4 is going to go here, our 2 is going to go here, right? So things we've done before, right? Factoring x plus 2, x minus 4, right? 2 times negative 4 is negative 8. 2 minus 4 is negative 2, right? Now we're going to take that one step further and solve each set of parentheses when it's equal to 0, okay? So I'll take my first one, x plus 2 equals 0, and then x minus 4 equals 0. And then very simply, I'm going to minus 2 here to get x equals negative 2, and plus 4 here to get x equals positive 4. So x is negative 2, or x is positive 4. Okay. Now, when you have this situation here, right, where you have just a variable plus a number and a variable plus a number, right? If you just want to take the kind of a quick shortcut, you just say, oh, if this is plus 2 here, I know my answer is going to be a negative 2, right? And same here, if this is a negative 4, my answer is going to be a positive 4. It's the opposite of what's being done here, right? Now, if your x has a number in front of it, then you have to do through the equation. But if it's just a letter by itself, you can just say it's the opposite of what the symbol is in there. Okay. All right. Let's do y plus 5 squared equals 21. Okay. So now we have something that's not equal to 0, right? And that's fine. We can still solve. Okay. So really, once again, we're solving for y, right? We're solving for y in this situation. Now, in order to get y by itself, we have to get rid of this parentheses, right? As we've done in the past, as PEMDAS says, right? But we looked at our parentheses has an exponent. It's squared, right? So we have to get rid of this square here. Well, how do you get rid of a square? How do you get rid of something that's squared? Well, you do the opposite of something squared, which is to square root it, right? So we're going to square root this whole side here, which means we have to square root my 21 here. Okay? Now, when we do this, all right, this square root cancels out the square here. Okay, that cancels out, and it's going to leave us just what's in the parentheses, y plus 5. Okay? Now here, square root of 21, we do not get a rational number with that, so we're just going to go ahead and bring down square root of 21, okay? And we're going to it's going to be a plus or minus, right? Now, why the plus or minus, you ask? Well, when you do the square root of a number, right? The square root of a number, let's just say, let's pick a perfect square, let's pick 9, right? Okay. So the square root of 9, we know is 3, right? Positive 3. But it can also be a negative 3. Because remember, 3, something that's square root, it's the number times itself, right? So positive 3 times a positive 3 gives us a positive 9, right? Well, and the same thing, a negative 3 times a negative 3 also gives us a positive 9, right? Because negative times negative is a positive. So in this case, both numbers, both 3 and negative 3, are the square roots when we square root 9, okay? So when we're doing this problem here, we have to put a plus or minus the square root of 21 because it's going to be whatever that number is, a positive and a negative of that same number, okay? And that does matter. You'll see in a second. So now our last step to get y by itself here, right, is just to move this 5 minus 5 here. So when we do that, our 5's cancel out here. We bring down our y, right? And then this part here, we're just going to leave it. We're going to go plus or minus the square root of 21 minus 5. Right? And that's going to be our final answer. Okay, we're done. Okay, we've got the y by itself. Technically you could, excuse me, you could square root 21, get a decimal, and then go through the process of this, but in terms of our case, we're just going to leave it just like this, okay? So, if you have a square root like this up top here, or a square, sorry, square root each side of the problem, okay? And then once you get down here, you have what's left of what's underneath, in the parentheses here, underneath that square. Move the number over to the side, to the opposite side of the equal sign, and then what you have left is what you have left, okay? Now, just to show you guys, excuse me, show us if we had here, if this is a different number, let's say this was 16, right? We know the square root of 16, right? It's perfect square, it's 4, right? But in this case, it would be a positive and a negative 4, okay? So then when you went through the process, you would have to do both sides. You have to do a positive 4 minus 5 and also a negative 4 minus 5, and you could actually get your answers here, okay? So that's how that would work if you had a perfect square, positive, negative of that actual number, and then go ahead and carry it on with the process. All right. Another example: 4x squared minus 12x equals 0. Okay. So now we have something like this, right? This is something that we can just go ahead and find GCF, right? We can just pull out the common factors of each term of our 4x squared and of our negative 12x, okay? So if we pull out, so let's look at the numbers, right? 4 and 12, okay? So what number do they both have in common that they can be divided by? Well, 4, right? Because 4 divided by 4, is 1. 12 divided by 4 is 3, right? So if we can pull out the 4 of each number, right? They can both be divided by 4. Now look at our letters. We have x squared, x here, which means yes, we can pull an x out. They have an x in common, so we can pull that out as well. Okay, that's all we can pull out. So what do we have left? Well, we have left is in parentheses. So we have 4x. We took out over 4x squared. So what's left? Well, we still have 1x left, right? Because 4x times x is 4x squared, right? And then we have a minus, and then 12 divided by 4 we said was 3, right? Now our x we already took out, so there's no x left in here, and it's going to be equal to 0, right? So all I did was this, I factored it, okay? That's all I did. I pulled out, I can divide each of my numbers here by 4, I pulled that out. I have an x on each one, I pulled that, one of those out. I can't pull 2 out, remember, because this one only here only has 1, so I can only pull out 1x, okay? And then what do I have left? An x for my first one, and a negative 3 for my second one, okay? Now, this part, we're going to go ahead, we have two sets. We have our 4x, we have our x minus 3. I'm going to set each one equal to 0. So 4x equals 0, and then x minus 3 equals 0. Okay, so I just split it up again. Put my 4x down, my x minus 3 down. And I solve for each one, solve for x. Obviously, I divide by 4 on this one. X equals 0, 0 divided by 4 is 0. And then over here, I'm going to add 3 here, and x equals a positive 3. So x equals 0, x equals 3. Okay. So that's how I do it for looking like this. A lot of examples I know, but this hopefully will help make sense. So 25x squared minus 60x plus 36 equals 0. Alright, so big numbers here, right? So first, this is what we call, we're going to square, this is factoring a perfect square trinomial, okay? So here's what that means. We look at our first and our last terms, okay? We have 25x squared, we have 36, okay? Now that means both 25 and 36 are perfect squares, so they can be square rooted. So how we're going to write this is in the form, we're going to square root our first term, okay? The square root of 25 is 5, right? Now our x squared can also be square root to get x, right? The square root of x squared is x, right? Now, we're going to break this down by doing this, okay? So 5x squared equals 25x squared, okay? But we're just going to break it down like this, okay? Now if we go to our last term, our 36 here, what's the square root of 36? It's 6, okay? Now what do we have left in the middle is this negative 60x, okay? So what we're going to do is, because it's a minus here, we're going to put a minus here, we're going to put 2, and then we're going to put our squares from our first and our last term. So we're going to put 5 as in parentheses, and also 6 in parentheses. Okay? Alright, so now we have 5x, so we broke down this whole thing, right? So if we were to solve this, right, we just broke it down, we factored it out, right? So if we took the second row and put it back up here, right, 5x squared equals 25x squared, right? 2 times 5 times 6, well if we do 2 times 5 is 10, and 10 times 6 is 60, right? Sorry, this x is going to go in here with our 5. Okay. Sorry, that's on the fly. 5x, because our x is here, right? 6. Okay. And then 6 squared is 36, right? So we just broke it down, okay? Now, we're going to break it down even more, okay? So, we're going to take our first term here, 5x. We're going to put a minus in the middle. We're going to take our last term, 6, put it here. and then we're going to put all this in parentheses with the square. Because once again, this here, okay, this, we're breaking this down. This equals this, okay? Because if you were to factor this out, and you don't have to write this down, but if you look, this square goes to both, right? So 5x squared, right? 6 squared, and then we have in the middle, 5 times 6, double that, right? So it all makes sense, okay? And then we have that equal still to 0, okay? So that's how this is going to work out. Now we're solving for x. Now we're going back to our previous problem that we did, where we had to get rid of this square here, right? So get rid of that square. We got to do square root on both sides. Square root on both sides to cancel out this square here. We're left what's in parentheses, 5x minus 6 equals, the square root of 0 is just 0, okay? Solving for x, two-step equation. We got to move this 6, so we're going to add 6 to this side here. Bring down our 5x, and 0 plus 6 is 6. And then we're going to divide each side by 5. And x equals, we can just leave this as a fraction, 6 over 5. Confusing? Possibly, yes. I know, I see that, okay? But in this case, once again, just to kind of go over the rules real quick. First and last terms, square root each of them, okay? Because they're perfect squares. 25 and 36 are perfect squares. So square root each to bring them down here. Square root of 25 is 5. Square root of 36 is 6, okay? Because 25 has x squared, we bring down the x with it, and then we put the square on the outside. Okay, we're just breaking it down. Okay, 36 equals 6 squared, right? And then to get the middle term, we put 2 first, and then we put our first term, 5x, our second term, 6, okay, in parentheses. And then here, we bring this down, bring our first term here, our last term here, put it in parentheses with the square root, and then you have the rest. Let's do one more example here. Let's do x squared minus 49 equals 0. Okay, so this one is pretty simple. Okay, so we're looking, we have x squared, we have a minus 49. Now we know we can square root 49, right? Square root of 49 is 7, right? And it's also negative 7, right? Remember. So we're going to go ahead, we're going to put this in our two parentheses here. We have x squared, so we have the x in front, right, by itself. And then we have a positive 7 and a negative 7. And then we're going to go ahead, and because we have x, but x is by itself in here, we know that our answer here is the opposite. So x equals a negative 7, and then here x equals a positive 7. And just to do the workout for you if you want to see, I have x plus 7 equals 0, x minus 7 equals 0, and then we're going to go ahead minus 7 to get x equals negative 7 plus 7 to get x equals positive 7. Okay, so that's it when you have x squared minus a perfect square. Square root of that number, positive and negative, flip the signs, boom.